Okay, time for the last of the new information for this unit, which is review, so I guess we can't really call it new. But this is percent yield. Remember, percent yield is just telling you how close you came to the amount that you should have ended up with. If you do your lab perfectly, you'll get 100% yield. It's very difficult to do that. It's not really expected that you do that, but this calculation allows us to get an idea of how close we are. For example, if you're supposed to get 100 and you get 99, that's good. If you're supposed to get 10 and you get 9, that's not as good. If you're supposed to get, 1 and you get 0.9, that's really not as good. And this percentage allows you to be able to calculate how good or bad your situation was. So the equation is percent yield equals the actual value over the theoretical value. By actual value, that means the lab value, okay, what the student found in lab. By theoretical, that means what the math tells you. So this one is based on your stoichiometry. So your calculation tells you what should happen, and your lab procedure tells you what really does happen. So for this problem, the first thing we need to do is we need a balanced equation. So it says it's the combustion of CH3OH. So combustion means reacts with O2 to make CO2 and H2O. You should know that. That's something we covered before. The balancing for this is 2, 3, 4, 2. If you want to practice that one, you can go back and take a look. So what we're going to do here is the first part of the problem asks us to figure out what the theoretical yield of H2O will be. Again, when it says theoretical yield, they're just saying do the math, okay? Do the math of the problem. It sounds fancier than it is. So you're going to take 125 grams of CH3OH and convert it into moles. For every 1 mole of CH3OH, you have 32.0 grams. So, and then we have our mole-to-mole step. So moles of CH3OH goes on bottom, and moles of what we're trying to find, which is water, goes on top. The coefficients are a 4 and a 2. And then moles of H2O on bottom, and converting into grams. 18.0 for every 1 mole. And remember, we're not going to round this answer. Well, actually, you know what? The first question is asking us for this answer, so we will round it for that portion of the question. The unrounded answer is 140.63 grams, and we should have 3 sig figs. So the first part of your answer would be 141 grams of H2O. It is what the theoretical yield would be for this problem. That's what we should get. Now we're going to calculate the percent yield because the problem told us how much the student actually got. The student got 136 grams. So that's going to go on top, and then on bottom is going to go the theoretical yield. In a problem like this, you could use the unrounded or the rounded. Down here, it'd probably be better to use the unrounded, but I won't mark you off either way. And then, of course, times 100. We're going to round to sig figs, 3 sig figs. So we're going to end up with 96.7%. And that would be your percent yield. So we were pretty good, pretty close on this one. So just take what's found in lab divided by what you should have gotten mathematically.